Hello everyone. In this section we'll learn about prism and refraction of light through prism. So a prism is a wedge shaped, transparent or an optical medium bounded by 5 surfaces of which 3 are rectangle and 2 are triangle. Remember, it is an optical or a transparent medium, that means light can pass through it. So I have a figure to show you which is like a prism. So this is exactly a prism. Since it is made of plastic, light cannot pass through it, but it is like a prism shaped. So in a prism you can talk about 5 surfaces. See, this one rectangle, this one rectangle, and the last one which is rectangle. So it has got 3 rectangular surfaces, and this one and this one, these are the 2 triangular faces. So a prism is a wedge shaped, transparent or an optical medium bounded by 5 surfaces, right, of which 3 are rectangle and 2 are triangle. There are certain terms you need to know about a prism. That the rectangular face over which the prism rests, I'm talking about the rectangular face over which the prism is resting, is called as the base of the prism. The 2 rectangular surfaces, you can see these are the slant. So the 2 slant rectangular faces are called as the refracting faces of the prism, or simply refracting surface of a prism. So these 2 slant surfaces are called as refracting surfaces. This is the base of the prism. These 2 slant surfaces meet at a line. This line is called as the edge of the prism. So we have got 2 rectangular surfaces or 2 refracting faces of a prism meeting at a line called as refracting edge, and the angle made by these 2 rectangular surface is called as the prism angle or angle of refraction, or sometimes we call it as refracting angle. So these are the terms you need to know about a given prism. So one of the rectangular face over which the prism rests is called as the base of the prism. The 2 rectangular surfaces which are slant are called as the refracting faces of the prism. The line over which the 2 refracting faces meet is called as the refracting edge of the prism, and the angle made by 2 slant surface, I'm talking about this angle, this one is called as the prism angle. This angle is called as the prism angle. And if I cut a vertical section of a prism, right, so by cutting the vertical section of a prism, I will get a triangular section of a prism which is called as principal section of a prism. So to study the refraction of light through a prism, we have to consider a principal section. So here I am talking about ABC. This ABC represents principal section of a prism, and A is called as the prism angle. We have to consider an incident ray incident on one of the refracting face of the prism, and we have to study the path of a ray of light through a prism. So whenever a ray passes from one optical medium to another optical medium, we have already studied that if it is passing obliquely, then definitely it will bend away from its path. The bending could be towards the normal, or the bending could be away from the normal. So whenever light is going from air to glass, it will bend towards the normal because it is traveling from rarer to denser. And after that, from one refraction, there is another surface AC where the refraction of light takes place. In that case, light would be traveling from glass to air, that is from optically denser to optically rarer, and hence it will bend away from normal. So we have to study the path of a ray of light through a prism, for which I will consider an incident ray. Now let's say this PQ, I considered it as incident ray which strikes the refracting face AB of the prism. And if I say if the prism was not absent, the light would have travelled along a straight path. I would name it as PP dash. So in the absence of prism, the light would have travelled along PP dash. But now it is travelling from air to glass, that is from rarer to denser. At the point of incidence, we should draw a normal. So I have to draw normal over here at the point of incidence. So this is the normal at the point of incidence. Now since it is traveling from rarer to denser, it's going to bend towards the normal. So I will draw this as the path of the prism. So this here QR, I would name it as a refracted ray. Now again it is traveling from denser to rarer, so it will bend away from normal. So again I have to draw a normal over here on the refracting surface AC of the prism, and now you will see the ray will come out of the prism like this. So this RS over here is called as the emergent ray. RS is called as the emergent ray. So we have PQ as the incident ray, QR as the refracted ray, and RS as the emergent ray. We have got two normal M dash and normal N dash. So we have got two normals over here. So if I retrace the emergent ray like this, so let's trace back the emergent ray. So what I am getting is that it is touching the original path somewhere over here. You can say that if the prism was absent, the light could have traveled along PP dash, but due to the presence of prism, it gets refracted at one face AB, and again it gets refracted at one face AC. So the final path is like this, RS. If I trace it backward, we can see the original ray has got bended by this amount, by this angle. So this is the incident ray and this is the emergent ray, S dash. So the angle between the emergent ray and the incident ray is called as the angle of deviation. So remember, this angle is represented by del, and here del is called as angle of deviation. So this is very important. For a prism, the angle of deviation is the angle between emergent ray and the incident ray. Now we have got other angles to represent in the figure. The angle made by incident ray with respect to normal is called the angle of incidence I. The angle made by emergent ray with normal is called as angle of emergence E. We have got other two angles, that is angle made by refracted ray with this normal as well as with this normal. So this angle I would name it as R1, this angle I would name it as R2. So whenever you are asked to draw refraction of light through prism, you have to draw a proper principal section of a prism. You have to draw a proper diagram where you would be considering a prism angle A and the points B and C. You have to draw an incident ray, then you have to continue the incident ray, and then bending it at one surface and then bending it away at the other surface. When you trace it backward, you will get the angle between the incident ray and the emergent ray, which is called as angle of deviation. So some angles are very important over here, and there are certain relationship between this angle, but remember, the derivation of this relationship are not required at all. You just need to know the relationship between this angle. The first relationship I am going to tell you is that angle of prism A is geometrically over here is equal to R1 plus R2. You need to know this relation. So this prism angle A will be numerically or geometrically equal to R1 plus R2. No need to give the proof of this formula, but you just need to remember that for a given prism, whenever a light passes through one face of the prism, it emerges from the another face. Okay, so what relation we have got? A is equal to R1 plus R2. Other relation we have is that A plus del का value will be I plus C. That means A plus del will be equal to I plus C. These two relations are very important for a prism. But over here, one more important thing, that whenever a ray of light passes through a prism, it emerges out of the prism, right? But the emergent ray is not in the direction of incident ray. You can clearly see. So two important things also need to consider, that here angle of incidence is not equal to angle of emergence. Second, the emergent ray is not parallel to incident ray. If I talk about refraction of light through rectangular glass block, in that case angle of emergence and angle of incidence were equal, and the emergent ray was also parallel to incident ray. But here the reason is that the two refracting face AB and AC are not parallel, whereas in rectangular glass block, if I talk about two refracting faces AB and CD, these two refracting faces were parallel to each other. And since the refracting faces were parallel, this is the reason proved that I was equal to E and emergent ray was parallel to incident ray. But over here, the refracting faces AB and AC are not parallel to each other. So here I is not equal to E in case of prism and emergent ray is not parallel to incident ray. So whenever a ray of light passes through a prism, right, it bends towards the base of the prism. You can clearly see that the emergent ray RS is going towards the base of the prism. That means it is going towards the thicker part of the prism. What you need to remember, whenever a ray of light passes through a prism obliquely, it always bends towards the base of the prism or towards the thicker part of the prism. If it is incident normal to one of the surface, it is not necessary that it is normal on the other surface. So even it is passing normally to one surface, again the deviation or the bending of the ray will be towards the base of the prism, that is towards the thicker part of the prism. So for a given prism, if a ray is refracted, there will be two refraction. One refraction will be at surface AB, other refraction will be at surface AC. In first refraction, the ray is going from rarer to denser, so it is bending towards normal. In the other refraction at AC, the ray is going from denser to rarer, so it is moving away from normal. And if I draw the emergent ray backward, I'll get the relationship between the incident ray and the emergent ray. They meet at some point over here and they trace some angle. The angle between the emergent ray and the incident ray here is called as angle of deviation. So we have got some important angle, and I have already told you the relationship between these angles. The angle of prism, that is the prism angle, is equal to R1 plus R2. This is geometrically proved but not required here at all. And A plus del is equal to I plus E. So this is very important relation. Now I have to tell you the relationship between the angle of deviation and the other factors of the prism. That means on what factor this angle of deviation depends. So if I talk about the factors affecting angle of deviations, so if I talk about factors affecting angle of deviation, so first factor is refractive index of material of prism. Refractive index of material of prism, and I will also give you the relationship that angle of deviation is directly proportional to mu, that is refractive index. That means greater the refractive index of the medium, greater will be the angle of deviation. Remember, angle of deviation is directly proportional to mu, that is refractive index of material of prism. Second relation you can clearly say from this only. I have already told you that if in refraction of light any factor depending on the refractive index, then it has to depend on the wavelength of light. So next will be wavelength of light. I am talking about color. Now the angle of deviation is directly proportional to refractive index. That means it has to be inversely proportional to wavelength. So here angle of deviation is inversely proportional to wavelength of light. Yani greater the wavelength of light, lesser will be the deviation. That means on a given prism, if different colors are incident at the same angle, what we will see that the color having least wavelength will get deviated by maximum amount. If I talk about the spectrum of white light, the red color has got the maximum wavelength. So for red color, wavelength is maximum, so deviation will be least. Whereas for violet color, the wavelength is least, so the deviation will be maximum. We will learn this in the next section or in the next chapter called spectrum, where we learn the dispersion of white light, right? So in that section I will tell you how the ray gets diffracted by different angle. So refractive index, one of the factor, other factor is the wavelength of light, third factor is the prism angle. Prism angle I am talking about A, and here angle of deviation is directly proportional to prism angle A. That means greater the prism angle, greater will be the angle of deviation. So you need to remember the three factors over which the angle of deviation depends. One of the factor is the refractive index of material of prism, and it is directly proportional to it. Other factor is the wavelength of light, that is color, and angle of deviation is inversely proportional to wavelength of light. third factor is the prism angle, and angle of deviation is directly proportional to prism angle. The fourth factor which I am going to tell you is very important, and so many questions are asked on this concept, but you have to focus this. This is very important topic. If I talk about the last factor, the last factor is nothing but angle of incidence I. Angle of incidence I. So a graph has been plotted between the angle of deviation and angle of incidence. I cannot tell you how the graph has been derived, because it has been derived experimentally by incidenting the light at different angle and observing the angle of deviation. So what we have done is we have plotted a graph of angle of deviation versus I, and this is just a experimental observation, and the relation we got between del and I is like this. So this is graphical observation, remember, this is graphical observation. And what do we learn from this graph? So this is the graph plotted between the angle of deviation and angle of incidence for the refraction of light taking place through a prism. And what do we observe from this graph? That as the angle of incidence initially increases, you can see, as the angle of incidence initially increases, the angle of deviation decreases. Can you see in the graph that as the angle of incidence increases, the angle of deviation decreases, and at certain angle, this angle of deviation becomes minimum. Remember, as the angle of incidence increases, the angle of deviation decreases, and at a particular value of angle of incidence, the angle of deviation becomes minimum. Now what happens at this angle of incidence? That angle of incidence is equal to angle of emergence. This is very important relation. That means if I talk about refraction of light through rectangular slab, in every case the angle of incidence will be equal to angle of emergence. But in case of prism, angle of incidence will be equal to angle of incidence is equal to angle of prism only in the case when angle of deviation is least or minimum. So remember, at angle of minimum deviation, angle of incidence is equal to angle of emergence. And now what if I increase the angle of incidence further? If I increase the angle of incidence further, you can see the angle of deviation also increases. So this is a very important relation. If I talk about the dependence of angle of deviation on angle of incidence, so you have to say, so these observations are observed from the graph which is plotted experimentally. And what do we learn from this graph is that as the angle of incidence initially increases, angle of deviation decreases, and for a particular value of angle of incidence, this angle of deviation becomes minimum, and if the angle of incidence is increased further, angle of deviation increases. You can also see from the graph that for different values of angle of incidence, let me see, if I talk about this value of angle of deviation, it occurs at this angle as well as this angle. That means for this angle of incidence, I1 as well as I2, there exists only one deviation. For this angle of incidence, you can say I1 dash and I2 dash, there exists this angle of deviation, but for this value, there exists angle of minimum deviation. That means for every angle of deviation, there exists two angle of incidences. But for angle of minimum deviation, there exists only one angle of incidence, which is I, or you can say it is equal to E. So what happens at the angle of minimum deviation is very important. I'll rub this graph now. This is very important. So at del is equal to del minimum, what happens when angle of deviation becomes minimum? So you have to say, sir, angle of incidence is equal to angle of emergence. And remember, when angle of incidence becomes angle of emergence, so R1 and R2 ka value will be equal, because we have already studied in the principle of reversibility of light that if a ray of light traveling from air to glass at angle I, if it gets refracted at R, right, while going from glass to air, if it is incident at R, then it gets refracted at I. So remember, what happens at the angle of minimum deviation? I becomes E, and R1 and R2 ka value becomes numerically equal. Very important. R1 becomes R2, and I would name it R. I have considered, let's say, R1 and R2 का value becomes R. So what I'll get, A का value was R1 plus R2, right? I have already given you this relation. So putting R1 and R2 का value R, I get A का value 2R. So what will be R का value? A by 2. This is the mathematical relation I have observed. It can be used to solve certain number of numericals only if it is asked in the question. So what happens at the angle of minimum deviation? I becomes E, R1 becomes R2, and if I write the formula del plus A, which was I plus E, so here del ka value will be I plus E minus A, and if I write del ka value as del minimum, remember, if I write del ka value as del minimum, I becomes E, so I plus I will be 2I, so the angle of deviation ka value, minimum deviation ka value will be 2I minus A. One more important thing I have to remember, that at angle of minimum deviation, R1 becomes equal to R2. So if I draw it on a figure, that if I have got a prism and angle of deviation is minimum, so R1 is equal to R2. So you have to say that in that case, the refracted ray QR is parallel to base BC. So these are the certain things you need to remember, because here this is I, this is R, this is R. So again this becomes I, which is equal to E. So what happens at the minimum deviation? Two things you need to remember. So angle of incidence is equal to angle of emergence, so that R1 is equal to R2. Second most important thing is that the refracted ray is parallel to the base of the prism. So in the exam it can be asked that what is the relationship between the angle of incidence and angle of emergence if the refracted ray is parallel to the base. So remember, if the refracted ray is parallel to the base, I becomes E, and what is the angle of deviation? Angle of deviation is minimum in this case. So all these things you need to remember. No proof is required. You need to know the certain formula about the prism whenever a refraction of light takes place through it, and that was A was equal to R1 plus R2, del plus A was equal to I plus E. And if I tell you the factors on which the angle of deviation depends, so the angle of deviation depends on refractive index of material of prism, right? It depends on wavelength inversely proportional, it depends on prism angle, and depends on angle of incidence. If I talk about angle of incidence, then I have got a graph like this, which says that as the angle of incidence initially increases, angle of deviation decreases, becomes minimum for a particular value, and if angle of incidence is increased further, the angle of deviation also increases. What happens at the angle of minimum deviation? I becomes E, R1 becomes R2, or you can say refracted ray is parallel to base of prism. Thank you.